There is no doubt in the fact that self-control is a great virtue, but humans, controlled by emotions, make erratic decisions most of the time. Machines, on the other hand, are very sophisticated when it comes to controlling. I mean, they can perform the same task a million times without sulking about it. In this video, we will be talking about the special function registers of 8051 microcontroller. These registers, abbreviated as SFR, controls various operations of the microcontroller. Let us check them out. If you are familiar with the architecture of 8051 microcontroller, you might remember that it has 128 bytes of RAM. Well, that is not entirely true. The 8051 microcontroller has 256 bytes of RAM divided into two parts, a 128 byte general purpose area and a 128 byte special function register space. The general purpose register space stores all the data that generates during the execution of program. In contrast, the special function register area maintains a set of special function registers that are responsible for managing the various operations occurring in the microcontroller. The special function register space starts from 80H to FFH, can be accessed by the programmer using direct addressing to configure them to perform specific tasks. But storing normal program data in this RAM space is not possible. Therefore, the 8051 microcontroller has an effective general purpose RAM space of 128 bytes, that is from 00H to 7FH. Looking at this picture, you might be wondering, can one place data in the empty space? Well, it is not possible to write data in the SFR space even if some places are empty, as they are kept free by the manufacturer to add functionalities to newer version of the same microcontrollers. Now that you know about this hidden memory space in the RAM, let us talk about various registers that compromises the special function register space. Control specific special purpose register. Power control PCON. The PCON register is responsible for managing the power mode of 8051 microcontroller. It is placed at the address 87H and it is not bit addressable. In most embedded system devices, power management is the biggest constraint for any developer. The 8051 offers a power down mode and an ideal mode to decrease its power requirement. In the power down mode, the clock of the microcontroller is frozen, stopping all the operations of the microcontroller. This drops the voltage requirements for the working of microcontroller from 5 volts to 2 volts and the current demand reduces below 60 microamperes. During power down mode, the status of all the special function registers and input output port remains the same, and only way to wake up this sleepy microcontroller is by using a hardware reset. When the microcontroller comes back to its normal mode after the reset, the values of all the special function registers are lost, but the data in the general purpose RAM remains the same. In the case of ideal mode, the most power hungry unit, the CPU of the microcontroller, is turned off. All other peripherals like timer, serial communication and interrupts keep functioning normally. Also, the status of CPU, accumulator and stack pointer remains as it is. There are two ways to pull the 8051 microcontroller out from the ideal mode: an interrupt that changes the value at PCON 0 or a hardware reset. Here what the inherit of PCON register contains: the SMOD. This SMOD what it does is the baud rate in serial communication doubles when this bit is being set. We will be discussing about the serial communication in detail in our course. You just keep in mind that this SMOD, serial mode, is going to double the baud rate when it is being set to 1 in serial communication. Then these bits GF1 and GF0 are general purpose flag bits, and this PD is nothing but of power down bit. When this bit is set to 1, the microcontroller goes on into power down mode, and this ideal bit is nothing but of ideal mode bit. If this bit is being set to 1, then the processor enter into ideal mode. The microcontroller does not use the reset of the 3 bits. Timer mode. TMOD stands for timer mode, and as the name suggests, it is responsible for setting the mode of a timer among other things. It is a 8-bit register that is placed at the address 89H in the ROM space, and it is not bit addressable. What this means is that each value in 8-bit registers can't be changed independently. This 8-bit register is divided into two 4-bit registers to manage T0 and T1 respectively. The lower 4-bit manages the modes for T0 and the higher 4 manages T1. These 4 bits are gate, C bar T, M1 and M0. The gate. Most microcontroller needs a way to start a timer. In this case of 8051 microcontroller, there are two ways to start the timer by external hardware or software. The gate register in TMOD is used to decide how the timer begins. If it is 1, if gate is equal to 1, then the timer will start up using hardware. If it is being set to 0, it will start by software mechanism. When it receives a control signal from TR1 in the TCON register, next about C/T bar. These timers can be used as both timer and counters to keep timer and to count external events. To use it as a timer, the C bar T bit is set to 0, whereas if it is being set to 1, it needs to be used as a counter of events. And M1 and M0 bits, these are 4 modes of 8051 offers. This means that we need 2 bits to set this mode. If M1 and M0 are of 0, 0, then mode 0 of timer counter is selected. If it is of 0, 1, then mode 1 of timer is being selected. If it is of 1, 0, mode 2 of timer is selected. If it is of 1, 1, then mode 3 of timer is selected. So under different modes, the timer counter is going to act in a different manner. Under mode 0, it is going to act as a 13-bit counter. Under mode 1, it is going to act as a 16-bit counter. And under mode 2, it is going to act as a 8-bit counter with auto reload. And under mode 3, it is going to act as a split timer 0 into two 8-bit counters or stop timers. We will be discussing about this timer and counter also in detail in a separate video. You just know what the special function register has and what is the duty of the timer mode in this video. Now the next thing is nothing but of timer control TCON. Now that we have got TMOD out of the way, let us go to the next control of special function register that is used by the timer is TCON, timer control. The timer control TCON stands for timer control and is used to send the control signal for functioning of the timer. The TCON register is bit addressable and it is placed at the address 88H in the ROM. It is an 8-bit register which starts the timer and also contains the flag which gets updated. TF and TNOD are timer flags that indicates overflow condition in timer 1 and timer 0 respectively. When an overflow condition is reached, the value is changed to 1 from 0. TR0 and TR1 are used to start timer 0 and timer 1. When a value 1 is loaded into these registers, the timer starts counting from the value which are inside them. You might be wondering, what is this overflow? Well, it is just like your water tank reaching its complete capacity and overflowing. The 8051 has two 16-bit timers which counts up from 00 to FFFFH. Once the timer reaches a value of FFFFH, it has no more values it can count up to making it overflow. But unlike spilling water in the case of your water tank, the microcontroller resets the value to 000H and sets the TF1 TR0 bit to 1, telling the programmer that the timer is overflowed. Let us say your microcontroller is busy performing some mathematical operations, and in the middle of that some activators need to be serviced. In such case, the external interrupts comes in handy. An interrupt in essence is a way to stopping the microcontroller's current operation and making it perform some other task due to higher importance. The 8051 microcontroller has two external interrupt ports, P3.2 and P3.3, to manage external devices of high priority. To alert the microcontroller peripheral devices, it can either be an edge-triggered interrupt or low-level signal which triggers the interrupt. IT1 and IT0 are used to select which kind of signal will be used to interrupt the operation of microcontroller. If IT1 is set to 1, then a falling edge signal will be seen as an interrupt, whereas if it is 0, a low level signal for a certain duration will be used to interrupt the microcontroller. If IE0 and IE1 are used to tackle the problem of looping inside the interrupt, which occurs during external edge triggered interrupt, the CPU sets IE1 and IE0 as 1 when it encounters an edge triggered signal at any of the two ports. When this bit is 1, the CPU ignores any other falling edge signals on the port, preventing reoccurring the interrupt. We have talked a bit about interrupts in the previous session, but to make them clear, let us have an analogy. Let us say you are sitting and watching your favorite TV show, and in the middle of your favorite scene you get a phone call. Now you have to pause the show and attend the call. The interrupt is like a phone call for the CPU. It forces it to pass all its works and tend to the interrupt, that is phone call here. Using interrupts can help you to optimize your program by effectively using CPU's resource. The interrupt enable register is used to manage the 6 interrupts the 8051 microcontroller has. By default, all the interrupts are turned off and need to be turned on by the programmer. The interrupt enable register is a bit addressable register and it is placed at A8H address. To enable any interrupt in 8051 microcontroller, EA bit needs to be set to 1. By default, it is set to 0 and no interrupts are enabled. ES bit enables serial communication interrupts when 1 is inserted into it and is disabled when the value is 0. ET1 enables the interrupt for timer 1 when it is set to 1 and is disabled when it is 0. EX1, this bit is used to enable external interrupt 1. ET0, this bit is used to enable the interrupt for timer 0. EX0, it is used to enable the external interrupt 0, and the rest of the bits can be used by the programmer. The interrupts in 8051 microcontrollers have certain priorities assigned to them. It helps the microcontroller to decide which interrupts to serve before if two of them occur at the same time. The priority of the microcontroller interrupts are as follows: external interrupt 0, timer interrupt 0, external interrupt 1, timer interrupt 1, and serial interrupt. To change the priority of these interrupts, the interrupt priority register is used. Note, if two bits in the interrupt priority register is raised, then the priority mentioned above are used to make the decision on which interrupt will be served. If any bit in the interrupt priority register is set to 1, then the priority of the interrupt increases. PT2 increases the priority of timer 2. PS increase the priority of the serial interrupt. PT1 increase the priority of timer 1. PX1 increase the priority of external timer 1. PT0 increases the priority of timer 0. PX1 increases the priority of external interrupt 0. The 8051 microcontroller can communicate with peripherals using serial communication to manage this asynchronous communication between devices. The serial control register SCON is used. The SCON register is placed at address 98H and it is bit addressable. SM2, this bit is used to enable multipurpose communication in mode 2 and 3. The REN bit is used to enable or disable receptions. TB8, 9th bit, is stored in this register during mode 2 and 3 while transmitting. TB8, RB8, this RB8, in RB8, 9th bit is stored in this register during mode 2 and 3 while receiving data. T1, this interrupt is raised by the software when the transmission is complete for a block of data. RI, this interrupt is raised by the software when a complete block of data is received. We will study the serial communication in 8051 in detail at the later video. A microcontroller would be rendered useless if it could not communicate with various sensors and actuators in its environment. The I/O related special function registers help the microcontroller manage these ports effectively. The 8051 microcontroller has 4 I/O ports, all of which have 8 pins. To manage these ports, there are 4 special function registers which are bit addressable. The main job of these 8-bit special function register is to set the direction of data flow from each pin. If a bit is set to 1, then the pin acts as an input port. If a bit is set to 0, then the port acts as an output port. Apart from the above mentioned registers, there are few other registers which help the 8051 microcontroller. They are accumulator, stack pointer, program status word, data pointer, and serial buffer. We have discussed about the functionality of these special function registers while we are discussing about the architecture of 8051. Well, we all hope that we had a control mechanism like 8051 microcontroller so that we went to the gym every day, but unfortunately the only thing we have is self-control.